In this video, we're going to take a look at sketching hyperbolic functions. So to begin with here, let's take a look at sketching y equals sin x. Okay, so hyperbolic sine of x here. So let's just write down the exponential definition here. So what I've got is e to the x minus e to the minus x all over 2. Okay. Now, if we think about this exponential definition here, this is basically the average of y equals e to the x and y equals minus e to the minus x. Okay, so y equals e to the x and y equals minus e to the minus x. Okay, because we're dividing it by 2, it is essentially just the average of these two curves. Okay, what I want to do now is sketch y equals e to the x and y equals minus e to the minus x. So let's do this in two different colors here. So for y equals e to the x, let's do that in red here. So it should hopefully be nice and straightforward. It will cut through at 1 here. And it's obviously got this asymptote here with the x-axis, and it will just curve up like that. Okay, so if I try and draw something that will look like that, we're going to get something that looks kind of like that. I am doing it on a tablet, it's never the easiest. Okay, something like that. Okay, so that's my y equals e to the x there. And let's do y equals minus e to minus x now in a different color. Let's do that in blue here. So for y equals minus e to minus x here, what will we get? Well, it looks pretty similar. The only difference is now we start in the bottom left here and we go towards this x-axis here. Again, this time now we cut through minus 1. Okay, so that's minus 1 there. So again, we're going to cut through at minus 1. Get closer and closer to the x-axis like that. Okay, it should maybe be a little bit steeper kind of down here. Like so let me just get rid of those first two lines there. See what it looks like when we draw this now. A blue pen here. Let's say we get something that looks like that. It's not perfect, but you get the idea here. So that's y equals minus e to the minus x there. So in that case then, for y equals sin x, it will be the average of these two curves here. So if I do that now in orange here, then it's just going to fit perfectly kind of between these two curves. It's the average. Okay. In that case, we get something that looks like this here. It cuts through the origin. It goes up like that. So it's going to kind of curve back up like that. Again, my curve's not perfect, but that's the main idea here. So it cuts through the origin, 0, 0, and we go from the bottom left here, cutting through the origin, and back up to the top right there. Okay, so that's y equals sin x there. Okay, so there we have it. So that's the sketch of y equals sin x. Let's take a look now at sketching y equals cosh x. So let's take a look now at sketching y equals cosh x. So y equals cosh x here. Well, to begin with again here, we just need the exponential definition. So this is e to the x plus e to the minus x all over 2. Okay? So again, because we're dividing it by 2 here, we're essentially just averaging these two curves here. So y equals e to the x and y equals e to the minus x. Okay? And again, all I need to do here is sketch these two curves. So I'm going to do this one in red here. If we sketch this one first, we have already seen a sketch of this. It cuts through positive 1, see there. And it has an asymptote here with the x-axis. I cut through, it's going to look, say, something like that. Okay. Join this up here. We get something that looks like that. Okay, so y equals e to the x. Now what I'm going to do is sketch y equals e to the minus x. Okay, so again here, what we're going to do is sketch y equals e to the minus x. Now this time it will also cut through 1. We'll also cut through 1 there. But this time now we just mirror this with the y-axis here. So we come from the bottom right here, or the right hand side, cut through 1 and then go up towards the left like that. Okay, so try and draw this here. Again, this is never the easiest, but let's see what we get here. We're going to get something that looks like that. Okay, not brilliant, but it's not too bad. So y equals e to the minus x there. So then finally, let's sketch y equals cosh x here in orange. So y equals cosh x here in orange. Now, like we said, this is the average of these two curves here. So in that case, then y equals cosh x will also cut through 1. And y equals cosh x has a parabolic shape. So it looks like a parabola, a positive parabola. It's got this kind of like U shape. Okay, something like that. So all I need to do here is average these two curves here. And I get something that looks, say, like this here. And it should be symmetrical. Whether my diagram will present that, we'll wait and see. But like I said, it should be symmetrical here about the y-axis. So if I try and sketch this here, we get something that will look like that. It's not perfect, like I said, it should be symmetrical about the y-axis, but you kind of get the idea. We've got this kind of parabolic U shape. Okay, so that's y equals cosh x there. And like I said, it intersects here with the y-axis at positive 1. Okay, and there we have it. So that's our sketch of y equals cosh x. So now let's take a look at sketching hyperbolic tangent. And finally, let's take a look then at sketching y equals tan x. So the first thing I'm going to do here is use the hyperbolic trig identity for tan x. So I can express this then as sin x all over cosh x. Okay. So in this case, we also have an exponential definition here, which we established in the previous video. So this is e to the x minus e to the minus x all over e to the x plus e to the minus x. Okay. So the first thing to consider here is what happens when x equals 0. So where does it cut through the y-axis? So when x equals 0 here, what do we get? Well, in that case, it's going to be sin 0 over cosh 0. We get sin 0 over cosh 0, which in this case will be 0 over 1, which is 0. Okay? So we know a sketch of y equals tan x will cut through the origin here. Okay? Now, sketching y equals tan x is a little bit tricky. What we need to do here is consider the behavior of the limits. So what happens here as x tends to positive infinity? So as x tends to positive infinity here, what actually happens to tan x? Okay, well, the first thing to note here as x tends to infinity is this minus e to the minus x will tend to 0, as well as this e to the minus x. Okay, but what I'm going to get left with then is e to the x over e to the x, which in that case means that's going to tend to 1. So in that case, e to the minus x will tend to 0. So therefore, tan x here will tend to 1. Okay. So as x gets larger and larger, our curve here is going to tend to 1. So I say 1 is here. Okay. It's going to go all the way up to 1. So it's going to look, say, something like this here. Okay. Have an asymptote here. It'll look like that with an asymptote being at 1. And then what we need to also consider is what happens as x tends to negative infinity. So as x tends to negative infinity here, what actually happens? Well, in this case, e to the x will tend to 0. And same again here in the denominator, e to the x will also tend to 0. So in that case, I'm going to get left with minus e to the minus x over e to the minus x, which in that case would give me minus 1 there. Okay, so as x tends to negative infinity, e to the x will tend to 0. E to the x will tend to 0. And therefore, in that case, tan x will tend to negative 1 then. Okay? If I say negative 1 is here, and it's going to go down So -1, and have an asymptote there. Okay, I might need to bring that down a little bit, but it's going to look, say, something like that. Okay, so we're going to have two asymptotes here. Do those in orange. That here. Let's just say that's my y. That's my point 1 there. So I have an asymptote here at y equals 1. And we also have another one here at -1. Can never say that's -1 there. I'll have an asymptote there. Okay. Y equals -1 there. So our asymptotes. So asymptotes here. Y equals fan x are y equals 1 and y equals -1. Okay. So there we have it. So that's our sketch of y equals fan x. Like you need to consider the limits there, or the behavior as x tends to positive infinity and as x tends to negative infinity. But there we have it. So that's the sketch of, we're doing a different color, match the same color here, of y equals fan x there. Okay. And there we have it. So that brings us to the end of this video on sketching the hyperbolic trig functions. In the next video, we're going to take a look at the inverse hyperbolic functions.